Hello everybody, welcome to my second video. Today I'm going to continue my old topic. I could have not completed it due to I did not want to take more time. So in today's video we are going to continue. Till last video we had done the pictorial representations of number sequences, and today we'll continue. So let's start. So yeah, as we were talking about, today we are going to continue. So as I told you, till last class we completed pictorial representation of some number sequences. Today we are going to continue at this topic. Just look at the screen. You take the pen. Yeah. This is the 1.4 topic. I'm just writing it like that. In the NCERT it is given like this, which is relations among number sequences. So as I told you at the last class, I'll just tell you some brief like a small explanation. So the last class I taught you about the pictorial representation of number sequences, visualizing number sequences by using pictures. Over here it's given, and then even further we learned that about the some examples of number sequences. And today we are going to continue from relations among number sequences. Okay, so let's start. So in this, sometimes number sequences can be related to each other in surprising ways. You know that. So let's scroll down and I'll show you some examples. So I think so. All of you know about the squares, right? Like one square, then two square, then three square, then four square. Do you know about the different tricks that you can get to know about it? Watch here and then you'll get to know. See, I change the color. Yeah. So see now, let's move to what happens. Okay, I'll ask you a question. For an example, what happens? What happens when we start adding up odd numbers? Okay, let's see. So you know squares, right? Just remember, one square is 1, two square is 4. You can, or if you want, I'll send you in my chat. I'm going to send you like in my description. I'll send you a photo about the odd squares, right? You can remember that. Then so today we are going to learn some example. Okay. So what happens when we start adding up odd numbers? So let's start. Let's see it. Okay. This is 1 is equal to 1. Of course we don't need to add anything. Then 1 plus 2, sorry, we need to add odd numbers, so 2 won't come. 1 plus 3, which is equal to 4. Okay, then 1 plus 3 plus 5, which is equal to as you can see here, which is equal to 1 plus 3 is 4 and 4 plus 5 is 9, so which is equal to 9. I'm not going to write all the examples. I'm going to write only some of them. Okay, then 1 plus 3 plus 5 plus 7. We are adding up the odd numbers. So equals to, this will be equal to 16. Okay. Now here you can let's draw division like a division line, and here we'll write. Write the squares. 1 square is equal to 1. 2 square is equal to, can anybody tell me? I just solved it. Yeah. 2 square is equal to how much? 4. 3 square is equal to, can anybody say? Yes, 9. 4 square is equal to, 16. And so you can see that here after we added the, I'll just change the color for clarification. After we added the odd numbers and we found the square of each number, we got the same numbers. You can see such a nice relation between these. Just see. Here's 16. When we added these odd numbers, you got 16. When we added these odd numbers, you got 9. So these are the some relations between the number sequences. Okay, so I don't want to mess the board more, so we'll just do this much. Okay, so you can see we have a nice relation between these two. So this is one type of relation. There are many relations. I'm not going to like tell all of them because I'm teaching NCERT, and in the NCERT they have not given all the relations. So this is one of the relation. Oh, this is such a beautiful pattern, right? You can see, like, it's such a surprising pattern, as I told you at the starting, right? It's sometimes number sequences can be related to each other in very surprising ways. See how surprising is this? So let's continue. Now here, uh, most of you people might have a question. Not most of you, but yes, some of you. Why does this happen? Okay, why does this happen? Do you think it will happen forever? Uh, the answer is yes. This this pattern this pattern will continue. This pattern continues forever. It never stops because we have infinite numbers, and in that infinite numbers we can have many odd numbers also. Okay, so I just wrote it. You can note down. Okay. Now, but why? But why does this happen? How is this related to it? So as I mentioned earlier, here you can see, as I mentioned earlier, the reason why this happens is just as important as exciting as the pattern itself. You can see, here the pattern is given. So this is like, you can't specify any relation. Okay. So this is like a relation which is matching to the odd numbers, because you're squaring the numbers, which is equal to the sum of odd numbers when you're adding one by one. Okay, so it's very important and exciting as the pattern itself. Okay, and then uh, a picture can also explain it. Okay, like by using, I'll tell you the picture later. How? I'll draw a line and change the color. No confusion, nothing. Okay, so visualizing with a picture can help explain the phenomenon. Okay, so as I wrote before, I'll show you visualizing the see, visualizing number sequences can be visualized using it. Here I have written more fruitful. It's a very nice and fruitful way to use this by using pictures. Okay, so let's see now. How can we partition the dots in a square grid into numbers of dots 1, 3, 5, 7? Now, as you got to know that this is like when you're adding. Can you get to know this through a square grid? Think about for a moment before reading further. Okay. So I'm just giving you some time. Think. You can type in the chat. You can pause in the video. Do it by using the square grid and type it in the chat. The answer. How did you do it? Okay. So now here's how it can be done. Here's how. Okay. Now you see we have a square grid. We'll take the number till 6 square. Okay. So first we have a square grid. Let's see square grid. We are going to make 6 tables like this. It won't take so much time. I'm just going to do like this. Yeah, 1 second. Okay. 1 second, guys. Yeah. So let's make 1, 2, 3, 4, 5, 6. We had 6 dots over here. Now 6 dots over here. Okay. Like this, we are going to draw 6 tables. Okay. Because we want to represent it using grids. Okay. So I'll not take more time. You can make do 5 seconds further the video, 10 seconds. Yeah, I'm just done. See, this is the last table, and yeah, here we are done. This is the last. Okay, now let's see the relation between them as I draw it. So the relation is, see, first this is, if we just for reference, if we draw one line, this is how many dots? 1 dot, isn't it? Now we'll do here. We'll just surround it. The grid will surround it. How many dots are these? Sure. How many dots? 3 dots. Everybody know counting. So in this way, let's do this. Let's make a table which is covering the stuff. Okay, 1 2 3 4 5 6 1 2 3 4 5 1 2 3 4 5 6. Okay, so I've made a table over here. I think so I've messed up a bit. I'm just not going to do it. This was messed up. Let me make it a little more nice. I think so you can't understand. I'm sorry. Okay, so let's start again. This is 1 dot, 3 dots. We're surrounding it. We're surrounding the area around it. Okay, so now at the first place, at this place, how many dots can you see? 1 dot. The second place, 3 dots. Maybe grid, in the grid you're able to see through. At the third place, you can see 5 dots. So like this only, if you add all of them, this is a square grid, okay? Remember, I told you at the starting. So this is a square grid, 1 dot, 3 dot, 5 dots. Now in the other thing, and in the other, the fourth row, we have how many dots? 7 dots. So in the same way, if you see, you will get to know that it's giving the same thing as the odd numbers. 1, 3, 5, 7. You can see here, right? Plus 9, plus 11. So this equation actually is, as you can see, 1 plus 3 plus 5 plus 7 plus 9 plus 11 is equal to 36. So this is his square. So after adding numbers, you got to know the square. So basically this square grid is also a fruitful way, isn't it? It's a fruitful way to represent this. This is one more relation. This makes it evident. This is making it evident, right? This makes it evident now that what 1 plus 3 plus 5 plus 7 plus 9 is equal to 36. Okay, I hope you understood. Now let's move to the next topic without wasting time. Okay, let's change the color so that you don't have any problem in understanding. Okay, so now let's see. Okay, here we saw the relation between them. Such a picture can be made for square of any size, right? If you can even find, like here, if you just add 1 and 3. First, if you add if you add only 1 and 3 here, if you add only 1 and 3, you'll get how much? 4, which is equal to what? 2 square. Okay, so here 4 is basically equal to 2 square. So you can make any size, or you can even go for like about 10 square by adding these all. Like here we have made only 1 2 3 4 5 6. If we draw about 10 squares over here, we can find out the 10 square, but we won't do that because it is very time taking. So let's continue to our main topic. Okay, now now by drawing a similar picture, can you say what is the sum of first 10 odd numbers? Yeah, it's easy. We can do like first here we just did 5, so you can just do like this. I'm just taking out some questions. Okay, so can you find out the first 10 odd numbers? Sure. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus, like that only you can continue, plus sorry, not 12, not 12, plus 13. We have done 7 plus 13 plus 15. Let's go here a bit. Plus 15 plus 17. I think so these are 10, right? 1 2 3 4 5. 1 2 3 4 5 6 7 8 9. Okay, one more. Plus 90. These are all the odd numbers. Okay, so when you add them, you get what you get, 180. Okay, I've used the shortcut method to do it. You can also if you have an iPad, you can do that. Okay, so it's equal to 180. Okay, so now let's see further. Okay, we are done with this. Change the color again. We need to, because I don't want you to get little so that you can differentiate with it. So let's not do that. Okay, so now by imagining a similar picture or by drawing it partially as needed, can you say what is the sum of the first 100 odd numbers? This is a big thing. I can't write it over here. If you want, you can try it in your home by drawing a grid or by using, or there is even a formula. In one shot, I'm going to tell what is the formula to find this out. Okay, in a short video I'll say what is the formula, and I'll even apply at the same question so that you can get into it. Okay, so let's move further. Here, another example of such a relation between sequences. Oh my god. First of all, this was a very, very surprising way. This was also a surprising way. Now, one more surprising way. Wow, let's see to it. What is that? What is that? What is that relation? I'll just write adding up. Up means up and down. Okay. I was telling by adding up and down. So yeah, how can you do this? You might not understand with the text, but let's just divide this and see. Okay. I think so. This is taking a lot of space. Okay. Adding up and down. Okay. So let's see how do you do this? Adding up and down. How do you do that? Question mark. How do you do that? So now let's see what I was talking about. So adding up means 1. First, of course, you'll write 1. Then adding up and down. So first we'll add up 1 plus 2, then down plus 1, which is equal to 4. Which is equal to 4. Then 1 plus 2. Again, we'll be continuing adding more numbers. Okay, 1 plus 2 plus 3 plus 2 plus 1. You see, I increased the number 3, and which is equal to, as you can see over here, which is equal to how much? 9. Then 1, 4, 9. Then in the same way, 1, we are adding up first. 2 plus 3, 3, we need to continue more. 4, then again plus 3, adding down, plus 2 plus 1, which is equal to how much? Can anybody write? Yes, sure, 60. So in the same way, we did all of them. So these are some examples. We can these are. So can you find the relation between these? Now you see. Okay, 60, 9, 4, 1. 1 square is equal to 1. Let's draw a line. 2 square is equal to 2 square is equal to 4, and then 3 square is equal to 9. You see, these all are matching. 1 square 1, 2 square 4, which matches to this. 3 square 9, which matches to this. Oh, 1 second, I think so I did a mistake. 9. Okay, it matches to it. Okay, and in the same way, 4 square is 60. I'm not going to write it. Okay, so you saw the relation again. There are so different types of relation. One is adding up and down. Here you can see. Another one is the square grid. I did not write it. Square grid. This is one more. This is the square grid. It is one example. Okay, and the other way was, this way was the normal adding up odd numbers. Okay, so let's continue. And I'm only going to take this class for 20 minutes. So I'm going to cover most of the topic. Okay, this is another way of counting the square things. Okay, so now I'll find the patterns. Now we'll start with a new topic. We are done with the relation. We are done with this topic. You know which topic? Relation between number sequences. Now let's move to our maybe last topic. Last topic, which is patterns and shapes. Let's write it. Point 5. Patterns. It's in the NCERT. It's written like this. So I'm writing exactly like that. Patterns in shapes. Okay, so let's study about it. So let's start. Yeah, so let's start. So here we have other important and basic patterns that occur in mathematics are patterns of shapes. Okay, so these shapes may be 1, 2 or 3 dimensions. Means these shapes may be in one dimension, 2 dimension or 3 dimension. You might know this. 1D is 1 dimension, 2D is like a flat picture, and 3D is like something like this. 3D is something like this. Okay, so these were I just showed you the examples of 1D, 2D and 3D, means which 1 dimension, 2 dimension and 3 dimension. Okay, or even in more dimensions. The branch branch of mathematics that studies patterns in shape is called geometry. Please note this down. I'll write it. The pattern in mathematics. Please note this down. Very important thing they might ask in exam. The pattern in mathematics that studies the patterns that studies. Oh, sorry, not pattern. One second. The branch. The branch in mathematics that studies the patterns. The patterns in what? The patterns in shapes. Okay. So this is, what is it known as? Geometry. So this is known as geometry. Okay. So as we were studying, this is known as geometry. Now let's continue. Okay. So let's learn about shape sequences now. Not a new topic. It's a topic of shape of the relation patterns in shapes only. Shape sequences. Till now we were studying about number sequences. Now we are going to study about shape sequences. Shape sequences. Okay. So let's start. These are one of the important type of shape pattern that mathematicians study. It's a what did they say? It's an important way. Okay. Many mathematicians have studied it, or many mathematicians have studied it. So it's a very important way. Okay, it's a very important way. Okay, so now if we continue, let's pick any random color of your wish. After some time, maybe I'll start some live classes also, but still for maybe 1 or 3 months, I'm going to do recording only. Then, okay, so important type of shape pattern that mathematicians study. Table 3 shows a few key shape sequences that are studied in mathematics. Okay, so I'm going to draw a table named table 3. Okay, so let's see what is the table 3. It's a pretty big table. I'm not going to continue more than 25 minutes. I told 20 minutes, but that's fine. Sorry for that. I'm thinking to cover this topic out. Okay, so examples of shape sequences. Okay, let's write it. Example of shape sequences. There are many examples, but we are not many examples, but we are going to cover most of the examples. So first we have I'll write for you in the box because it's all about diagrams. Sorry, not good. Okay, so we are going to draw. No, this is not nice. I'm sorry. Okay, so we'll just draw a table. If this time it does not come perfect, no, I'm not going to draw. Oh yeah, it came. Okay, so first we have triangle. I think so I'm not supposed to write. Everybody knows you. Everybody knows the shape, I mean. So this is quadrilateral. This is another shape. This is pentagon. I can't draw all of the shape. It's like pretty like the decagon and nonagon are a bit hard. It might take a long time. Okay, so this is what pentagon. This is this one. This one. This shape is what? Hexagon. In the next class I'm going to complete this. That's why I made a playlist for this. It's a pretty big chapter. The next chapter is lines and angles. It's a very big hexagon. And then in the same way we'll continue. It continues. At the last we have decagon. I'll try to draw it. It's a bit hard, but I can do anything to teach you people. This is a decagon. Okay, you see decagon. Okay, so I think so it's pretty hard to draw. I'll just write it over here. At the last we have decagon. Okay, so this so in between I'll just tell you heptagon. Heptagon has 7 sides. Octagon has 8 sides. Nonagon has 9 sides and decagon has 10 sides. So I just wrote the last one. You can make a note of it. In the next class I'll make this table and show you. Okay. Then we have complete graphs. These all are known as, you know what? Regular polygons. Okay. Then we have complete graphs. I'll just give some example. Complete graphs. In the next video I'm going to reduce the time of the video. Okay, because I think so this is my new channel, so most of you people don't watch these big videos, and I'm even going to put some shots about the questions. Okay, the complete graphs are like this. Complete graphs, I'll just draw it for you as fast as I can. This is one line which we represent as K2, means 2. It has 2 dots or 2 vertices. I mean, like, no, it does not have any vertex, but it is like two points it has. Then we have, in this we have 3 points, so this will be K3. In this we have 4 points, and in this you will draw a cross. You cannot match the points in the triangle because it's only 3 sides. Here K4, which is continued. In the next video I'm going to show all of these. Okay, which is continued and then goes to very high, but in the NCERT it's given till K6, which is in this shape. Okay, please remember to note this down in the next video. This video we won't take it so long. Okay, this shape you can connect it in many ways. You can see, right? You can connect this over here, you can connect this over here. Okay, then you can connect this over there. Okay, so these all connections are possible in this. You might say, oh my god, there are so many connections in this, right? And in the same way we have drawn many connections, like the points meeting to other points that I've drawn that connection. Okay, so the next one is stacked earth. I'll just do as fast as I can. Next one we have stacked squares. Okay, which are something like this. Sorry, not like this, something like this. Okay, so you see, upon one square, this is a square. Upon this we are stacking squares. Okay, so like in the same way we already stacked these squares, so in the same we need to stack more squares, something like this. See, we're stacking squares upon, which continues and goes forever, but in the NCERT it's given to 5, so we're just going to draw till 5. Oh shit, sorry. We'll draw till 5. 1, 2, 3, 4, 5. Okay. Okay, so these are 5. I'm doing a little fast so that it can happen fast. Exactly at 30 minutes, maybe I'll close it. These are stacked squares. Stacked squares. Okay, and then we have the next we have stacked triangles, which are something like this. Okay, so these are all stacked upon each other. So these are triangles which continue. In the next video, I'm going to show you this very clearly, very neatly. Okay. So today, okay. So this time I can't draw that nicely, but next video, please come. Please watch the next video. Surely I'll complete this chapter in the next video. Okay, these are stacked triangles. Stacked triangles. And then we have the last one, which is given in the NCERT. Okay, which are Koch snowflakes. These are a bit hard to draw. I can't draw all of them. I think I can't draw nicely. Sorry for that. And then this, what happens in, I'm going to tell you what in the next video, what happens in the Koch snowflakes. Okay, so it goes like this. Okay, so this call and continues and makes a, and it becomes a very hard snowflake. Okay, I can't draw that actually. Yeah, it's a bit hard. I can't draw that. But just think that Koch snowflake is like very contains very nice segments. Okay, so these are named as Koch snowflakes. Snowflakes. So today we covered till here only. I've been teaching till half an hour. Today we'll stop here. In the next video, I'll complete this chapter. Till then, bye bye. So,
So same. Okay. So okay.